Is it audible to everyone?
Yes, sir.
I request all the participants to join immediately. I request all the participants to join immediately. A very good afternoon to everyone. I am Bhaskar, Assistant Professor in Electrical and Electronics Department from Malla Reddy College of Engineering. It's my distinct pleasure to welcome you back to all the second section of day one of our FDP, 2 days national level EEE FDP on AI-IOT in electrical engineering applications. Now it's my immense pleasure to introduce our esteemed resource person of this second section, Dr. Chintalapudi V. Suresh Garu. Dr. Suresh is esteemed professor and head of the Department of Computer Science and Technology. He holds his post-graduation and PhD in Electrical and Electronics Engineering from JNTU Kakinada. With his rich experience of 14 years in teaching and 3 years in the research experience, and he has contributed to the academics and research community. And his expertise guidance, the two PhD scholars has already awarded the degree, and two more are in the thesis submission. And recognizing to his innovation, he has been granted a one national patent with another patent already published. He has an immersive publication records with 25 research papers across various international and national journals. He also has a 14 international conferences. He committed the research in the further expertise by the completion of the sponsored project by the Department of Science and Technology, which is around the 31 lakh with the DST New Delhi, that is the Department of Science and Technology. His contributions were further acknowledged with the prestigious Best Research Award from the JNTU Kakinada in the year 2018. He also instrumental in the establishment of the IoT lab in the VVIT University Guntur, and his very research experience are automation and with using embedded system, control design, developing the models, and development of artificial intelligence based on the algorithms to the similar real-time projects. Please join me in extending a very warm welcome to Dr. Chintalapudi V. Suresh Garu. Suresh sir.
Thank you, sir. Thank you. Am I audible? Yes, sir. It's audible. So is my screen? Sir, is my screen visible?
No, sir, not visible.
Can you able to see my screen?
No, sir.
Sir, can you able to see it?
Yes, sir.
I'm Dr. Chintalapudi V. Suresh, working as a professor of electrical and electronics engineering. leading the Department of Computer Science and Technology with specialization in IoT. Now coming to the today's session. Today you might have already heard in something like what are the different one second. Different emerging areas or trends. Can you able to see my screen completely?
Sir, no, sir. Your audio is resounding, sir.
My screen visible.
Now it's okay, sir.
Hello.
Sir,
Sir, am I audible?
it's okay, sir. It's audible.
It's fine. Now, today we will see. I don't know. I'm getting something like a. This is coming. Sir, am I audible?
Yes, sir.
No, sorry for the disturbance. I think my screen is also visible to you. Can you clarify once?
Sir, you go ahead, sir. No problem.
So shall I continue?
Yeah, you can continue, sir.
So IoT is not an engineering or not a theory. So it is basically a technology. So our main intention is identifying the basic applications and the advanced applications of anything. As it names the technology, the engineering has got an application orientation of or development of various applications for solving real-time problems or applications. Development of the applications is the main objective of any technology. Similarly, this IoT, Internet of Things, it has got two words actually. Internet is connected with different systems and the things. Things are nothing but various devices and the systems. If you see, basically, IoT is nothing but a networking of various systems which are interconnected to share the information or to exchange the status of each and every machine which are connected in a network. Repeating once again, IoT is nothing but an interconnection of various systems or devices in order to share the information or exchange the status of its working condition. So, sir, is my screen clear? I think. So a thing in the system or IoT is nothing but a physical object which is used to perform certain operations like monitoring of health using various health sensors or identifying the temperature using temperature sensor. Identifying the temperature and also various biosensors are used more as biomedical applications and various sensors which can be used in automobile applications. So these are the things as things in an IoT system is concerned. And these devices are interconnected. The Internet of Things is nothing but the internet is used to internet was is a word which was stated in the year 1999 by MIT's Audio ID Center by author called as
Sir, your audio is somewhat problem. Voice is not coming continuously, sir.
sir, is it clear now?
I think
Is
some
it
break
clear, sir?
between. Now it's clear.
Now it's clear now. Sir,
Yeah, sir.
yes. This word IoT is given by Kevin Ashton, now who can be considered as a father of the IoT. And if you see how IoT works and what we can do with this word IoT, uh, as I told you, IoT is nothing but a collection of multiple devices which are connected in a network. So IoT is nothing but a machine-to-machine communication. Earlier, we used to have human-to-human communication. Now the trend has changed from human-to-human communication to machine-to-machine communication. So this is a novel emerging technology which has got wide applications in various problems. For example, I'll tell you in the next presentation, I will show you some of the applications where we can use this IoT as far as this electrical engineering is concerned. So now this IoT technology or IoT systems works based on a life cycle called as IoT life cycle. So which consists of four major processes. The first one is collect, the second one is communicate, the third one is analyze, act. So collection is nothing but a collection of various sensors. Communication is nothing but a sending collected data to various devices. And analysis is nothing but a performing various analytical aspects of collected data. And action is nothing but initiating certain activities or something like actions which can be taken against the collected information. So this basics, let me move on to the advanced applications of this IoT. Now emerging and its applications to electrical vehicles and what the and coming to emerging trends, the word which gives us or which leads because of a word called as a smart. So addition of smart to every aspect gives us the development of these emerging trends. Machine learning, artificial intelligence, cloud computing, cyber security, deep learning, blockchain technology and IoT, all these different data science, data analytics, all these are the various aspects we can consider to be the part of these emerging trends. So machine learning, deep learning, artificial intelligence or data science, if it want to work, it needs the data, or all these emerging trends works based on the data. Whereas the IoT is a kind of separate technology where we have the provision to generate the data that is required for all these machine learning, deep learning, data science, and other emerging technologies. So as far as this electrical engineering is concerned, the first application what I have considered here is electric vehicles. How this IoT can be implemented in electric vehicles is the main objective of this 1 hour presentation. So electric vehicle, as we already know, it is something like a vehicle or a movable thing which is used to move some of the objects or persons from one place to another place. Conventionally, all these vehicles are equipped with different set of motors for the purpose of propulsion or for the so things from one place to another place. Electric vehicle is a kind of vehicle which uses electrical energy to move or to perform this kind of transition. So it has got different parts in it. On an overview, so it has got a charged batteries or batteries which are already charged or which can be charged, and battery system, we will call it as simply a battery system. And there is a motor which is driven by the supply which was stored in the battery system, so that the motor moves and the vehicle moves and the operation or the required operation. Fuel, petrol, gas, and electric vehicles uses battery system in order to drive the motor which is connected for the propulsion purpose. If you see the different types of electric vehicles, conventionally we have EVs. There is no IC engine, only electric drives are used. Electric drive is nothing but a motor along with its speed control mechanism. And we have a battery pack. Now its size is very, very large conventionally. It is around 20 to 80 kilowatt hours. For example, already in the market we have got Nissan, Tesla models. Hybrid electric vehicles is the second category of the electric vehicles. And here these hybrid electric vehicles has IC engine and electric motor. And battery pack of size 6 to 12 kilowatt hours. For example, we can hybrid electric vehicle. And we have in this hybrid electric vehicle, both electric motor is driven by the battery system, whereas the conventional IC engine is being driven by the conventional fuels. So whichever the part we want, we can use it. So, and also automatic operation, that is switching between these two different type of conventional fuel and the electric battery charge can be shifted automatically in these hybrid electric vehicles. And second, third category is plug-in hybrid vehicle. Electric motor, and the batteries can be charged from any external source. Whereas in hybrid electric vehicles, the batteries are being charged within the system. Whereas in plug-in hybrid electric vehicles, the batteries are being there is a possibility to charge the batteries from the outside any external source. And last one is mild hybrid vehicle, MHEV, where it has got IC engine, is driven by the conventional fuels, electric motor. This turns the engine, which is to braking, restarting, and all these can be possible with quite a quicker operations. So all these are the different categories of electric vehicles. And we already have the basic aspects, like with regards to electric vehicle charging systems and the stations. So in EV batteries, now conventionally we will use AC grid or maybe the solar panels which are fixed at some of the charging stations in order to charge the battery, which was used in the electric vehicles. Usually battery charge takes place around 7 to 8 hours charge from 0 to 100. And recently, due to the development of the capacitor technology, ultra capacitors and the super capacitors were developed, and which takes around 1 to 3 hours to get the full charging of the battery, which was used in the electric vehicles. And also, if you see, there are several advantages when compared to the conventional vehicles, like conventional fuel-based vehicles. Now, controlling is very easy. Speed control is possible. And automatic control and speed identification of the battery charge is very, very easy. So we can do low maintenance and low operation cost. So we have several advantages of using these electric vehicles when compared to the conventional vehicles. If you see the essential components in electric vehicles, as we already discussed, and as an electrical engineer, we already know. So these are the conventional parts we need to have it for electric vehicles, like a conventional motor. So nowadays we have something like a basic research and advanced research is going on towards the implementation of AC induction motors and also brushless DC motors. And we have got a controller to drive this motor, and this controller mainly used for different purposes that I will discuss it in the next slide. And we have got a converter or inverter operation to perform any conversion of AC to DC or DC to AC is needed. And we have a battery charging facility, and we have got a charger facility. So these are the main components where we have where we can find in electric vehicles. Out of all these five parts, now where can we find the application of this IoT, and how this IoT helps in electric vehicles is the main object. So in conventionally, motor has got a fixed set of design. Now where there is a need of these IoT devices to monitor the heat developed in the motor and or heat developed by the motor. And if you want to see and if you want to log the data of speed that is being maintained, which it is being something like what kind of heat is developed and what is the brush there. So there are different type of sensors which can be used to monitor all these health parameters related to the motor. And also battery charger, what kind of charger is connected, when the charger is connected, and what kind of heat is developed. And we can monitor all these parameters, and what is the current value, what is the voltage value, and if you see the battery, the state of the charge is the main interesting part and main objective. Now to have these IoT devices to be used in this battery monitoring or battery management system. And converter or inverter operation, conventionally controllers are used here for this purpose. The converter or inverter operation can be performed by using suitable IoT driven FPGA boards. And if you see the next essential components of electric vehicles, so this is a clear view and a complete view of electric vehicle. And this is the important concept where we can find the detailed applications of IoT devices in each and every aspect of this electric vehicle. So electronic control unit is the main unit, so which drives the electrical energy stored in the battery system to various parts of electric vehicle. So starting from normal charging conductor, where it uses DC to DC converter, so upper circuit, after that inverter, we have a motor driven circuit in order to drive the back wheels. And also electronic control unit, which is used to supply the electric power to various components in an electric vehicle, such as for braking system, for accelerator system, and also for lighting purpose, for giving a horn purpose, or maintaining the air inside the electric vehicle. Now, in order to do all these operations, there is a separate electronic control unit which is used to monitor or to perform each and every action. So, for example, if you see, normally power is being supplied from the power supply. So we have got two different type of charging facilities. One is a normal charging, that is using onboard charging, onboard charge. We have another facility called as a quick charger, where the separate environment is being situated in order to perform this kind of quick charging. So the charging stations are completely different, and the charging mechanism is also completely different. So which is used to slowly the batteries are getting charged, and the charge stored in the batteries is inverted and is being supplied to the motor, and motor drives the vehicle so that the vehicle moves from one place to another place. So this is a conventional way of performing work using electric vehicle. And the main important parts are motor. So nowadays AC induction motor or a brushless DC motor is used based on the type of motor used inside the electric vehicles. So the respective inverter and the converter systems are used. And if you see the IoT implementation here, as I already said, sensors used and the nature of the requirement, the respective motors are selected. And also controllers and the charger, where we can find these applications. And we have already seen the basics of IoT. And the main important point to be noted here is the change is internet. Evolution of internet is important here. So before the development of the internet, we used to have human-to-human communication. In this human-to-human communication, human comes to another place and he used to share the information with another one. So we used to have a fixed set of information transfer among or between two systems, which are operated by humans. So human intervention is very, very clear here in pre-internet era. Once after the evolution of internet, the first technology we used to have here is Internet of Content, IOC. So where this Internet of Content works based on World Wide Web. So where we used to have things like email operations, or information sharing operation, or information transfer operation, or information exchange operations, or for entertainment purpose, or if you want to gather any information related to anything, we can use this kind of internet for the sake of information exchange. So this is what IOC technology, where you now once these smart networks are developed, so we have the evolution of IOC technology. Next technology is iOS technology, which uses Web 2.0. Web 2.0 facilitates the users to develop e-commerce websites. That is e-productivity. So e-commerce websites and e-productivity is the main important outcome of iOS, Internet of Services, where it uses IT platforms, smart IT platforms, and offer different services for the users as per their interest and their requirements. So after this iOS technology, we have IOP technology. This IOP technology gives us the facility to exchange information among various people through social media network. So like we have conventionally YouTube, Twitter, Facebook, Skype. Now all these are the different applications and the outcomes of IOP. So these are the different social media platforms where the various people have been connected together and are exchanging information as per their requirements as and when they require. And the last one is Internet of Things. So this Internet of Things is the main outcome of the development of data-driven ambient context using smart devices, objects, and uses machine-to-machine communication. So starting from human-to-human communication to machine-to-machine communication is the outcome of IoT. And in my view, IoT is not the final stage of this kind of evolution of IoT. The next generation, that is the upcoming generation, is IoE, Internet of Everything. So IoE is the next technology, upcoming technology, where every device is connected and is communicated and exchanges information. So using this information, we have very confident and we are very confident to have the applications of this IoT in electric vehicles as to be the part of electrical engineering applications of IoT. So there are various applications where we can connect. This electrical engineering is being connected here towards this IoT, smart home applications, smart wearable devices, smart city, smart in IoT, connected cars or autonomous cars or driverless cars, and connected health, smart retail, smart supply chain management are the different areas where if you see from these statistics, we can identify so far how much is the development of IoT technology in various aspects. Now here are the top 10 most popular IoT applications I have given, and where we have at present or so far we have got something like 100% of the systems which are related towards the smart home are available in the market, and mostly or many of the people are using the smart watches and smart gadgets as a wearable devices in order to monitor their health regularly as and when they require. And these are of the areas of the applications of IoT. Find it for smart building, smart applications. And if you see the future of the IoT, now very confidently having the something like different sources, we can clearly say that in future we can count on where we in every area, which means in every area we can find the application of IoT. So we have LoRa modules, we have Zigbee protocols, and we have different available sensor is the main key. So application oriented implementations we can find here is why we have got 2G, 3G, 4G, 5G and 6G technologies is because of the need of having more number of IoT devices which are supposed to be connected in a networking fashion. For example, recently in central government has taken an initiation like no need in future or within no time or in near future we can in the on the highways, because once the vehicle or electric vehicle something like a approaches the highway system based on the global positioning sensor GPS of that particular vehicle. So your longitude latitude positions are being automatically captured by the uh, central level monitoring system, and starting to ending position automatically it calculates and in which direction you have traveled through your vehicle or by your vehicle is monitored, and automatically the toll gets necessary system. Sir, am I clear? Am I audible?
Yes, sir, you are
My
audible.
voice? Yes. Now, coming to the main important application of IoT in electric vehicles is BMS. BMS is nothing but a battery management system. If you see, for a battery, in order to store the charge in a battery, we need to monitor four different important parameters. The first one is the voltage, second one is a current, third one is the temperature, and the fourth one is vehicle acoustics. Voltage or current temperature acoustics. No, if you see in the market, we have got voltage sensor, current sensor, temperature sensor, and acoustic measurement sensors are available in the market. So all these sensors are calibrated with embedded devices in order to log different levels and the status of this voltage, current, temperature, acoustics of a vehicle. So this all these parameters and its data from a electric vehicle is logged by the embedded controller which is fixed inside a vehicle, and all this data is sent to the cloud in order to perform the three actions. The first one is monitoring of the vehicle health or condition of the battery, and the second one is in order to perform prognostics against its life, its remaining life, and the third one is performing prognostic analysis in order to take necessary actions or precautions in order to increase the life of the battery. So these are the three main objectives and how we can use this IoT towards battery management system. So state of charge is the main concept here. We will call it as state of X estimation. This X can be anything like state of charge, X can be charge, state of available power, that is state of AB, state of health, that is SOH. So in order to monitor the charge stored inside a battery of an electric vehicle, and in order to have a clear view of the available power so that your vehicle can be used in order to drive from one location to another location, and also state of health. So with regards to the braking systems or with regards to the electronic control unit, with regards to the horn, with regards to the lighting system, no, any kind of system, with regards to the something like a water flow system, with regards to the safety systems which are used inside the electric vehicle. No, now the state of X can be anything. So which is possible with the edge computing or edge intelligence which is used inside the electric vehicle. For example, edge computing and the cloud computing are the two different technologies. Edge computing is, the name indicates that some sort of computations and the analysis is performed at the edge of the device itself. So for example, battery monitoring system or in BMS, the voltage and the current are being monitored continuously by the sensors. In order to sending all these voltage and current values to the cloud every time, so automatically or unnecessarily it increases in network traffic, and also sometimes there may be a chance of loss of data also. So before being happening something wrong, so it is always necessary to take a necessary action in some of these applications like electric vehicles. So take considering all these or sending all these voltage current values to the cloud and taking necessary action may take some time. So in order to avoid a kind of any untoward situations or uncontrolled situations, it is always necessary to take a necessary action at the edge of the device itself. So whatever the embedded controller or a system which is installed or integrated in the electric vehicle to monitor this voltage and current, temperature and other parameters should log the data of all these parameters using the necessary sensors, and based on the values of all the sensors, the necessary precautions have to be taken and so that the corrective actions can be initiated. So prevention is better than something like a losing entire thing. So prevention is always better in order to initiate the corrective actions within correct time. So this kind of computations are performed using edge computing devices. It is always necessary to limit the state of charge. So if the charge inside the battery is somewhat less, obviously now the vehicle should alert the user. So it is a time to charge the vehicle at the, now what are the nearest charging station which is available. So now how much battery is how much charge is left in the battery. Now these kind of alerts that the user will get. For example, unknowingly or something like unwantedly or in a helpless condition, something is happened, like charge has been completely drained from the charging systems or a battery system. So where there is a need to travel 5 more kilometers to the charging station. So what we can do here is the complete information or nearest charging station information is available with the electric vehicle user. So because of connecting various things using IoT system, so that the user can easily approach the nearest charging station to have an alternative setup of having a auxiliary battery, so that the vehicle can be moved from present stop position to the charging station position. Like there are different advantages where we have got application of this IoT, and what are the major benefits of integrating this kind of battery management system with IoT are listed here. For example, a framework which is used to perform various functions in a car can be performed using various computational systems like edge computation system or fog-based computation systems. And sending updates and maintenance notifications from the car to the maintenance engineers. Simple example we have already taken, or to the car owner or a company, so that they can be guided by you. They can guide you so you can have your complete traveling without any disturbances. And maintenance is the energy stored in a battery. How much amount of charge is required? Do we have any facility of charging stations which are available while traveling? So where now we can clearly plan our scheduling based on the amount of charge that is available in the battery system. So as I already discussed, SOX is the main estimation which needs to be optimized, and battery diagnosis, how much when the battery was installed, how many days it has been used, how many working hours it has been used, how many watt hours it has delivered, so that it can able to clearly estimate what is the life of the battery and what is the remaining life of the battery. So far it has worked. So this is the main important point. Now how this IoT can be used in battery management system. That is the only example, one example I have taken and tried to clear management system applications using IoT. So the next one, what I have considered here is whole system approach. Name of the system, what we have considered here is whole system approach. That is V2X technology. V2X technology. In this V2X technology, the first V is called as vehicle. And the next V can be any one of these applications listed here in this figure. The first one is vehicle to mobilities. So one vehicle is automatically connected with another vehicles so that mobility can be performed. For example, from your location to another location, you want to move from one vehicle at boarding points at different stations. So the first vehicle carries you from starting position or source point to the first boarding point, and the second vehicle starts after reaching the first vehicle to the first boarding point, so that your mobility can be performed. So vehicle to vehicle communication is the main important here. The technology is called as vehicle to mobility approach, and the second one is vehicle to cloud. The best example we have seen here, BMS. The complete details with regards to the battery management system are sent to the cloud, means the details regarding to each and every part of operation is sent to the cloud for performing analytics on the data, so that preventive actions or preventive mechanism, preventive suggestions can be given, so that the corrective actions can be taken against any damage. And this kind of technology is called vehicle to cloud approach. And the third one is vehicle to infrastructure, V2I. So whatever the infrastructure available in the smart cities or on the highways, so clearly your vehicle can able to identify this infrastructure, so that any disturbances or without any problems. So this kind of approach, we will call it as vehicle to infrastructure approach. And the fourth one is vehicle to grid. So as I already discussed, so this electric vehicles needs different charging stations in order to charge the battery system used inside the vehicle. So the information related to the facilities of this grid charging stations is needed in order to plan traveling using your electric vehicle. So what is the charge, or what is the charge of what is the cost of the charge available in the particular station? So it has to be clearly analyzed so that you can schedule your charging process for your vehicle. And the next approach is to billing services. Once after completion of your charging process at a charging station, the bill has to be automatically generated, and finally payments have to be authorized by the respective owners in order to transfer the money from your account to the billing services or suppliers. And the next one is vehicle to pedestrians or persons, V2P. So first one is V2M, second one is V2C, third one is V2I, fourth one is V2G, fifth one is V2B, next one is vehicle to pedestrians or persons. So normally on roads we can find pedestrians or persons who are walking or who are crossing the roads. This vehicle should identify the persons or pedestrians on the road, and according to the position of the persons, our vehicle has to move its movements. That kind of approach we call it as vehicle to persons approach. And the next one is vehicle to device. Your vehicle should automatically communicate maybe its present longitude and latitude positions in the form of position to some other devices which needs this kind of authorization. For example, there is a need to track the present or correct location of the ambulance in order to provide sufficient emergency medical services to the persons who are in need actually. So the present or current position of the device vehicle has to be monitored, and so that the traffic at the nearest locations or nearest junctions can be cleared, so that the vehicle moves without any traffic. So this kind of applications or implementation can be performed in this through this vehicle to device facility or approach. And the last one is vehicle to vehicle. So this is a advanced concept or something like advanced mechanism where one vehicle starts communication with another vehicle. Let us see everyone in detail. The first one is vehicle to mobility approach. Mobility is nothing but a segment where actual increase of electric vehicles on the road will take place. For example, if you use conventional vehicles, so there is a possibility of increasing CO2 emissions in the environment, so that the air gets polluted, and obviously a long distance travel is always not possible with the electric due to its charging problems. So in order to solve this kind of problem, we have the vehicle to mobility technology. So all these electric vehicles are scheduled in such a manner that long distances can be traveled using this vehicle to mobility technology. So from the your source point, one electric vehicle has been engaged, and it takes you to the first boarding point. From there, the second electric vehicle starts. Likewise, that process is continued till you reach the destination place. So this is how the vehicle to mobility technology can be used through electric vehicles. Means the scheduling of electric vehicles at different possible places or boarding points can be scheduled as per the user's requirement, so that the cost of travel is minimized, the environment pollution can be minimized, the burden on the users can be minimized. There are several advantages of using this vehicle to mobility technology. Nowadays, we can able to see, in order to deliver some of the goods from one place to another place, these electric vehicles or drone vehicles are very popularly used. So these are in abroad countries, we can see in some of the videos, we can find there is something like autonomous robots or robot-based electric vehicles are being appointed and deputed in order to deliver the goods from restaurant or one place to another place. So this is the vehicle to mobility technology, and the next technology is vehicle to cloud. And as we already learned, the different operating conditions of electric vehicles with regards to the its position, current position, and the battery's charging station, and how many halts you have taken from your starting point to reach the destination point, how many hours you have traveled, and where we have taken different something like a repair mechanisms. Now each and every data is being completely logged and stored in the cloud in order to give you the precautions against any something like a future expected problems. So completely this vehicle to cloud technology needs the access of internet communication. So using internet communication, it stores or it sends the data to the cloud, so that in cloud there is a possibility to perform analytics on the data stored. For example, your electric vehicle is completely used continuously for 2 hours or 3 hours. So the battery and the motor which uses electrical charge, due to that the temperature is being developed. So there is a need to log the temperature values at battery place and also at motor place. By fixing the DHT11 sensor or DHT22 sensors or industrial based temperature sensors, and by configuring the embedded boards, we can log the temperature data continuously. And there are two possibilities. One is storing the entire logged or something like a collected temperature values within the system. Once the system is exposed or is being established a connection with the internet communication through Wi-Fi, automatically the entire stored data is sent to the cloud in order to perform analysis on the analytics on the data stored in the cloud. If the temperature data is stored and after performing the analytics, the user will get the alerts like the vehicle is being continuously used. So automatically it needs to take some 10 minutes rest in order to cool down the temperature, or we have to switch on the AC or a cooling facility which is available inside the vehicle so that the temperature developed across various parts can be minimized. Now likewise some of the alerts can be received so that your plan of traveling is not disturbed. So this is the ultimate aim of any technology in order to provide or in order to maximize the facilities and services for the users in order to maximize its extended facilities. And the next one is vehicle to infrastructure approach. So this approach, now if you see some of the figures I have given here, in order to understand this vehicle to infrastructure, this vehicle to infrastructure gives us the scope to develop various systems where your electric vehicle start communication with infrastructure which is available on the road. In order to perform this, we need another unit called as RSG, roadside unit. This roadside unit always gives the instructions to the vehicle who are traveling in the vehicle or who are driving the vehicle on its screen, or maybe in terms of the messages. Like, so this is the infrastructure which is in front of your traveling position. For example, there is a school zone, there is a hospital zone where your vehicle is not supposed to move, or something like a with higher speeds. So it sends the it sends the alerts to the user so that user may take necessary actions. So roadside unit is responsible for communicating the information related to various infrastructure available in that particular place to the vehicle, all the vehicles which are commuting in that particular road. Simple example we can able to see here. There is a red car which can able to identify and which highlights or which performs its movement based on the red light at the traffic. So if there is a red light, automatically vehicle identifies in that infrastructure there is a red light, so vehicle I is being automatically stopped. If there is a green light, so automatically moves towards forward direction. So likewise, one vehicle or every vehicle needs to communicate or needs to have the information related to the infrastructure in and around it. And the next one is vehicle to grid approach is something else which is very closely associated with electrical engineering especially. So conventionally we use AC grid systems and we maintain charging stations in order to charge the battery, which is battery system used in the electric vehicles. And there are several possibilities nowadays. We have renewable energy sources which gives us something like a less price, and there are some of the remote locations where we can find the establishment of these kind of renewable energy system based substations or charging stations, where the quantity of the charge and the quality of the charge and the cost of the charge available at these charging stations is something else different from that of the parameters available at the conventional grid system. The quality is very quite good and the cost is also very comparatively very less. So the conventional charging stations and the scheduling of the charging at these kind of renewable energy system based charging stations is completely different. So we need to identify where the charging station is available for free without any traffic in order to charge your charging system. So likewise, this kind of vehicle to grid approach gives us the complete information related to its charging stations and what is the cost of the charge at that particular charging station, whether the power is available or not, how much time it takes to get the charge of your battery. Now likewise, there are several facilities which provides to the user in order to maximize the utilization of this IoT technology to get a complete usage towards battery energy storage systems. And the next one is this process at the charging station has completed. Means a smart, flexible, end-to-end secure process of billing is needs to be completed. So in this particular billing process, there is an involvement of third-party authorization, like any of the banking services or payment service related applications which needs third-party authorization. Every vehicle or every device cannot be used in order to access your third-party applications or third-party transactions. But whatever the transaction you have done with your electric vehicle is authorized, you have to give authentication. This authorized transaction has been completed with the support of blockchain technology. So here we have used the blockchain technology means the entire process is some depicted in the form of different blocks of processes, sub-processes, and every block of processes is being authorized with respective hash keys and hash codes and the respective tokens. All this process of linking of the entire transaction or transactional process has been completed with the help of blockchain technology, so that your vehicle charging process and the transaction process has been completed. This is what we will call it as vehicle to billing approach. And the next one is vehicle to pedestrians approach. Vehicle to pedestrians approach or person's approach. Pedestrian means those who are commuting on the roads, persons who are commuting without any vehicle, by walk, by run, or by bicycle. They will commute on the roads. So a broad set of road users, including people who are walking on the roads or who are crossing the roads, children who are pushed on the strollers, people using wheelchairs, or people who are using bicycles or skating shoes. Now likewise, now all these cases can be considered as pedestrians. So if a pedestrian or a person who is moving on the road, now if a person is moving, what our vehicle has to do here is our vehicle has to identify the movement of the person, what he is going to do. Based on that, the vehicle has to take necessary action against his movements. So this is what we will call it as vehicle to pedestrian or vehicle to people movements. This is vehicle to V2P approach. So obviously there may be something like a chances of reducing number of accidents because of this kind of V2P technology or V2P approach. If once the vehicle is automatically stopped, once after it is being identified that there is a person who is crossing the road, automatically there is no possibility of getting accidents on the roads. And for example, if there is a crowd in one of the area, automatically vehicle is being guided with the amount of traffic which is available in that particular location, so that your vehicle can be scheduled in another route or another direction to reach your destination position. So this is what one of the finest technology, vehicle to pedestrian. So what we have here is the complete application of IoT in all aspects of vehicle to X technology. The next one is vehicle to device. For example, as we already seen, the internal construction of electric vehicle, there are various systems which are used in electric vehicles. For example, starting from power steering, engine control unit, ECU, electric motor, for weather purpose, seat movement purpose, or sunroofing purpose, wiper purpose, window purpose. So we have used electric drives or motors of various ratings. There is a TCU transmission control unit in order to control the vehicle movements, and there is a need of connectivity, TV module, audio system, and LED lighting system, and the keyless entry or central lock system, complete dashboard, reverse brake system, now diagnosis unit. Now there are various systems which need electrical power to control various or to perform various operations within the electric vehicle. For example, air condition flow by the air conditioner has to be controlled. What kind of movements you want to have it? Flap position or damper position or blower position? What kind of additional air conditioner operation you want to have it? Based on the situation around its electric vehicle, the necessary action is being automatically taken by the air conditioner. Like door mirrors and side mirrors, lighting system, backlight system. Now, all these devices or the devices which are used in the electric vehicle are being completely guided by ECU, electronic control unit. So this is vehicle to device system. There are various devices. All these devices should perform its integrated operation by connecting or by establishing networking among all those devices so that IoT and its objective is being served, like connecting all those devices and the systems in a network for the purpose of exchanging information or exchanging the status of one device with another device so that the other device or another device take a necessary actions in order to overcome the damage. And the last approach is vehicle to vehicle approach. In this vehicle to vehicle approach, nowadays we can able to see autonomous vehicles or driverless cars is the best example of this vehicle to vehicle technology or approach. If one vehicle starts its traveling on the road, it automatically shares its position with the global control system or global monitoring system to the respective servers using satellite technology, and similarly the other vehicles positions are also shared with the current vehicle or our vehicle, so that our vehicle takes its movement on the road so that then no accident or nothing is going wrong. So you can be reached from your starting station to the destination station without any issue. So this kind of communication enables the vehicles to wirelessly exchange its information about their speed, location, and your direction. So in which direction you the vehicle want to move. So all these aspects needs to be shared with other vehicles so that other vehicles can schedule its movements and its speed and its heading directions. So this is vehicle to vehicle technology. So conventionally it seems to be heterogeneous connectivity approach. Like what is the vehicle to X technology we discussed so far? Vehicle to vehicle, vehicle to house, or vehicle to pedestrians, vehicle to devices, vehicle to mobility, vehicle to infrastructure. So this is the V2X technology, and we have got the availability of different telematics like a global positioning system and its data monitoring system using satellites, and we have the availability of Wi-Fi, wireless fidelity, on various cloud-based systems or cloud-based monitoring and analytics systems. We have cellular-based networking facilities, which can be used in order to transfer the exchange the information from one location or from one device to another location or to another device. The purpose of infotainment purpose also. Infotainment means information plus entertainment. So what is the speed at which the vehicle is moving? What is the audio system or something like any seat entertainment purposes? So no, we have different types of infotainment systems. So all these systems are integrated within an electric vehicle in order to make the car more smarter. So this kind of approach, we call it as whole system approach, which is of heterogeneous in nature. The application of this IoT in electric vehicles emerges a new technology called as IoT, Internet of Vehicles. This Internet of Vehicles is a distributed network. As we have already seen, it needs to be communicated with several other devices, maybe towards the infrastructure or towards other vehicles or towards the mobility, no, towards the persons, no, which is a distributed network that supports the use of the data created by the connected cars and vehicular and ad hoc networks. We'll call it as VANETs. So these VANETs provides us a clear gateway and enroute the data of your vehicle or sensor data to another vehicle or another device. Simply, this diagram illustrates us a clear view in which direction the first car is moving, what is the distance to the second vehicle, what is the distance to be maintained by the third vehicle. Likewise, there is a information monitoring system, we call it as GCU, global control system. This GCU allows the different users to maintain the safe distance between the cars automatically without any human intervention, so that there is no need to worry about any accidents or untoward situations happens on the roads. The important goal or the main objective of this IOV technology is to allow the vehicles to communicate in real time with their human drivers, pedestrians, other vehicles, roadside units, and fleet management systems. So all smart cars in Internet of Vehicle technology must have a reliable connection towards the local communication channels. This is very, very important. And this IOV makes car sensor platforms more reliable, and automatically it increases the safer navigation, chances of minimizing traffic, and traffic can easily be controlled and managed. And the finest advantage of having this kind of IOV technology is to minimize pollution or environmental pollution. So the main objection why we are not using this electric vehicle technology is the two key problems have been identified and are faced by many of the EV users. The first one is charging facility. So it needs to be charged every time, and the charging time is one of the important key parameters to be addressed. So it takes quite something like a longer time in order to charge the battery system in electric vehicles. So it is very, very important in order to have a quite impressive technology in order to increase the usage of electric vehicles. And the second problem identified by the EV users is it cannot be used for driving longer distances. We have already addressed this problem of commuting or longer distances is through V2M technology, vehicle to mobility technology, sharing various electric vehicles at different boarding stations, so that all these vehicles are being operated by various persons or different traveling operators using electric vehicles, so that we can reach our destination with lesser cost without any pollution. So IOV technology allows the users to communicate each and every information of your vehicle with other vehicles and other units, roadside units and public networks using VANETs. So finally, I can say this vehicle to IOV, Internet of Vehicle, creates a network with intelligent devices as participants. Like we have already seen, vehicle to human technology, vehicle to infrastructure technology, vehicle to roadside unit, vehicle to sensors, vehicle to vehicle, Internet of Vehicles and its applications. If you see, the main architecture of IOV, Internet of Vehicles, it consists three different layers. The first one is perception layer, or a physical layer, which includes all sensors, quite different sensors. In my next slide, I will tell you what could be the possible list of sensors that can be used by an electric vehicle. So that all these sensors and its data needs to be handled by either edge computing devices or embedded system controllers, and should safely save this data for further analysis, for perform further analytics, so that preventive actions can be initiated. So there are three layers here. The first one is perception layer, which includes all sensors, all different types of sensors within the vehicle. This layer collects the data using all these vehicles and detects the events and driving patterns and various situations. And this entire information is already stored in the database, or maybe within this vehicle, or maybe towards the cloud. And using this data, the necessary activities or actions can be initiated. And the next layer is network layer. As the name suggests, that it can be considered as a communication layer. It communicates the data which is collected by the perception layer and transfers the collected data either through wireless LAN systems, or maybe using Bluetooth technology or Wi-Fi technology or 5G technology, or any sort of mobile networking towards the application layer. This application layer can be considered as a cloud-based storage systems or interface systems or analytics systems. The third layer is responsible for performing analysis on the stored data, and after performing analysis also it needs to be stored. The analytical results needs to be stored for further processing, and finally decision has to be taken against all these transactions. Finally, the ultimate aim is the work should perform with maximum efficiency, safety and infotainment. And the main challenges to be addressed to have this IoT technology, IOV technology, that is electric vehicle plus IoT technology, the main challenges to be addressed are poor network connectivity and stability. As the mobility of electric vehicles is increased, the number of vehicles needs internet access is increased, obviously. So obviously the current generation networking may not be able to supply sufficient networking or required networking connectivity for all the sensors which are used in the electric vehicles, is one of the technology. So obviously the main future scope here is the upcoming technology, 6G technology, may address few of the challenges to have this IOV technology into the market. The next hurdle here is hard delay constraints. Even though the data is being captured by the sensors at highest rate of collection, the rate of transmission is the main problem here. The band of the network is a main constraint, and the quantity of the data applied to the database is a major problem here. High reliability requirements. Obviously, transportation and the driving related applications needs highest reliability and the highest safety. So it needs to be addressed, is one of the challenge. High scalability requirements. So obviously one sort of every parameter in an electric vehicle using that single node. So obviously the number of nodes which are supposed to be installed in an electric vehicle should increase. If it is so, the number of nodes which needs internet access is increased. So the scalability is the major important problem to be addressed. This is one of the scope in IOV technology. And ultimately we have very something like in each and every technology we have a common challenge to be addressed here is security and the privacy. and the sustainability. Once the technology is being ready, and if it is working without any something like a sacrifices or without any discrepancies, obviously the scalability or saturation point is the main important aspect to be addressed for every technology. If once the technology has reached its saturation points, now further developments needs something like a customization is the one aspect here. So these are the some of the challenges to be addressed in IoT technology. So combinedly, we can see IoT is nothing but a sensors combined people or for the purpose of serving or offering different services for the people as per their requirements using 5G or networking communications using cloud systems and various actuators. So for this purpose, in order to have the application of all these aspects, we need this kind of IOV or IOM, Internet of Many Things, Internet of Everything. These are the upcoming technologies where we have the application of all this. So in future, in my previous statistics, we have already seen so far $14.4 trillion is the market gain by the Internet of Everything. So in future, cyber security or cyber physical systems is the next upcoming industrial revolution as far as the technology information is considered. So at present we are in industry 4.0, that is machine guided systems or intelligent based systems. We can say intelligent based systems. So that for the systems, intelligence comes with this kind of embedded systems, integration of these kind of embedded systems. So Internet of Things is the best technology which can be integrated to every systems in order to increase its intelligence so that it can serve the user purpose with more reliability and more efficiency. And finally, these are the some of the intelligent transport applications of IoT. And I told you that now this can be the last slide of this particular concept of IoT applications in electrical engineering. And these are the different type of sensors and its position. We can see one can consider any one of the sensors along with any one of the embedded boards and can suggest some of these projects for the students so that electric vehicle technology is the future ready technology for electrical engineering students. So during their study, if any student batch or if some of the students have worked on these kind of sensors and if they have developed any real-time monitoring systems and control systems using this IoT, so they may have a good opportunity in the market in this electric vehicle market. So some of the sensors, I can read it. Road condition sensor, magnetic sensor, vehicle distance sensor, side obstacle sensor, air pressure sensor, inside door lock, rear obstacle GPS, airbag sensor, rear view camera, and driver monitoring sensor, steering angle sensor. We have already seen electron control throttle, fire sensor, collision detection sensor. Now, message display system, hands-free system, and braking mechanisms, tire, something like a tire movement sensor. Now, we can see whatever the possibilities, we can have the respective sensors and the system can be integrated here. Now, in order to this, some of the projects which have been done by our students are the reference, and some of the systems I considered for this presentation. And let me show you some of the advanced applications of IoT as far as this electrical engineering is considered. Is my allow you? Can anyone? Sir, is my screen visible?
Yes, sir. It's visible, sir.
Yes, sir. Now coming to the other aspect of this application of artificial intelligence and the emerging trends in electrical engineering. So I considered very briefly, I will tell you, I cannot give you a detailed lecture on this because time is not sufficient for me. I'll give you whatever the points which are important as far as these emerging trends applications towards electrical engineering is concerned. So the topic name is application of artificial intelligence and machine learning techniques for the solution of large-scale RDS, integrated power system problems. Now we have in existence smart grid, microgrids, and risk management systems towards this electrical microgrids. And in artificial intelligence or intelligent grids, intelligent smart grid is the main thing. So the grid becomes smart grid because of the implementation of SCADA systems in the electrical power systems, supervisory control and the data acquisition system. So continuously in each and every substation at each and every control point, we need to monitor the voltage levels, current levels, power factor, frequency deviations, or frequency monitoring, phase angle monitoring. Now all these points and all these electrical parameters needs complete and continuous monitoring, continuous and complete monitoring. So for this purpose, we have got different units, pressure measurement units and intelligent based electrical energy monitoring systems, EMUs. We'll call it as energy monitoring units or EMS, energy monitoring systems. So obviously the conventional infrastructure becomes intelligent infrastructure. The first stage is smart infrastructure, then intelligent infrastructure. So what the difference here is, a smart infrastructure allows the users to monitor all the electrical parameters at each and every stage of maybe generation stage or transmission stage or distribution stage for the purpose of providing sufficient protection at each and every stage for each and every equipment used in this entire electrical systems. So this provision of protection or providing protection for each and every stage or every unit or every system needs some actuation signals to be generated by the different embedded systems. So if an embedded system wants to generate an actuation signal, it needs some control signal to generate based on the previous data. For example, continuously current flow through a particular wire is more than or nearer to its breakdown current value. For example, there is a fuse of 5 amperes. So the current flow through that fuse or a fuse wire is continuously more than 4.5 amperes or 4.6 amperes. Obviously, after some time, due to I square R heat loss, there may be a chance of breakdown of the fuse. So in order to take a preventive action against this situation, current flow through that particular wire is supposed to be monitored continuously. And automatically there is a embedded system which has been already trained by this artificial intelligence mechanisms through machine learning. When once the current flow through 0.5 amperes or more than that value for a period of 2 to 3 minutes, automatically switch off the breaker which is connected to that particular line. So the conventional smart grid system becomes intelligent grid system. Means intelligently it has taken a decision in order to save the necessary infrastructure in an electrical system. So conventional grid system and which in turn starts into systems. So once again, how this kind of smart grid helps to have a safer environment here is, we need to integrate various IoT based or ICT infrastructure within the electrical infrastructure to maximize the applications and to have more efficient and better management power infrastructure. And the integration of renewable energy sources into the conventional grid is a major challenge here, because the power generated by this renewable energy sources or wind or solar generation or power storage systems is not continuous over a period of time. So obviously the generated power have to be scheduled in a proper time in order to integrate or synchronize with the conventional grid system, so that the grid failure problems or the necessary power oscillations, which are power harmonics, which are integrated into the system, can be minimized and the load can be operated at safer limits. A better management of energy utilization is also possible with this kind of integration of IoT systems. And for example, the tariff system or in future surely the amount of usage with respect to hours, not only on the whole demand what we have got for our residential or industrial purposes. Something like this. For example, timely based tariff system means morning 6 o'clock to 9 o'clock the power tariff is something, and 9 to 12 something else. Likewise, for every duration, for every 3 hours duration or for every hourly duration, the amount of tariff will change. In that condition, obviously, the amount of electrical energy used from the grid has to be scheduled intelligently by the load centers automatically. So, for example, if you want to, if we want to switch on our washing machine for clothes washing purpose, what is the better time so that the minimum cost of charge can be considered? So, likewise, our devices becoming more smarter. Load smart grid is also minimized of operating the transmission lines or operating persons. ISOs at different transmission and distribution operators becomes very easy. For example, now this is a schematic diagram, a simple system where the smart grid performs its operations between different operators and the service providers with regards to the bulk generation. So whatever the generation station, wherever the generating station, whatever the power generated and whatever the cost of power generation, what is the quality of the power generated from by the generating stations. Now all these parameters are taken into consideration, and by satisfying the user contractual agreements between the different bidders and the different users, industrial customers and the domestic customers and the nature of the customers, the respective operators have to provide necessary connections between all these stations so that the power generated by the generating stations intelligently transfers through the transmission system and through the distribution system and serves the user for the purpose, for his purpose. So there is a nothing appliances. Now we have the possibility of usage of electric vehicles in this smart grid system also. So the charging of this electric vehicle can be scheduled based on this smart grid infrastructure. So if you see the conventional transmission system or systems to the integrated IoT integrated or renewable energy sources integrated power systems. So this is possible because of IoT systems, because the point of common coupling is the main point where it provides the sufficient connectivity paradigms in order to integrate a small set of microgrid to the major or main AC grid. Because in the microgrid or microgrid can be considered as an islanded grid which can be removed or which can be isolatedly operated within the within its system, because it has got its own generation capability and it has got its own load capabilities. Sometimes there may be a chance of need of additional electrical power which can be supplied from main AC grid, or there is another case, there is a surplus power generation from the microgrid which needs an integration of or supply of additional generated power to the AC grid. So in these two cases, the possibility of flow of power or exchange of power between microgrid and the AC grid is possible because of having the data of each and every parameter at each and every stage. So this makes the conventional grid system becomes a smart grid system, As we all of us know, DER is the one of the important aspect of grid operation distributed energy sources in order to have a high quality reliable electrical power. So obviously there is a need to decrease this electricity prices, which is not possible, and decreasing the demands, which is also not possible, and minimizing the chances of getting shortages or improving the poor quality. All these are the different issues to be addressed. The main problem here and the main solution what we can provide with the provision of these kind of smart grid or intelligent infrastructure is increasing demand can be provided and the number of chances of getting electricity shortages can be minimized. Quality or power quality can be improved, and the electrical price, as we have already discussed, can be minimized and by scheduling the loads at different stages. And if you see, these are the main important aspects where we can find the application of these IoT systems. This is the conventional power electronic control based controller systems, power electronic based control mechanisms here. Now AC to DC or DC to AC or output interface filter circuits. Now each and everywhere we need to monitor all these parameters. So what is the switching operation of various switches used in the controllers needs to be monitored, and what is the switching time, what are the switching losses, what is the temperature developed across each and every switch in a controller has to be monitored. Based on that, the converter operation can be scheduled. Interconnection microgrid and it main in operations, we need to have the data related to the current, frequency, power factor, parameters need to be monitored. That is possible with the equipment like voltage sensors, current sensors, and all those electrical related sensors. So all these sensors are integrated and equipped in the conventional grid system, so that this kind of data is logged and the necessary preventive and corrective actions can be initiated using artificial intelligence and machine learning algorithms. So all these are the conventional configuration PV integration systems. I don't want to go of all these. So let me have a clear view so that I can tell where we can find the application of this. Various mechanical based sensors can be integrated in this mechanical part of these wind systems, so that we can identify where we can get the possibility of low voltage right through LVRT problem, so that the power generated by this wind generating systems can be integrated to the conventional utility without any system, without any issues or VSIs and CSIs, voltage source inverter and current source inverters, and its scheduling, maybe using the battery systems or battery management system. All these are the different possibilities where we can find the application of these IoT systems. And conventionally, the grid operations and its data is being logged continuously, so that there is a possibility of setting up machine learning algorithms in order to identify or in order to predict the possible faults on the systems, so that preventive and corrective actions can be taken. Let me show you one more system. Now this is the energy storage technologies where we can have already let me show you. I have a slide for you. Yes, this is a microgrid server. Now, once after completion of the introduction about all these microgrids and smart grids, now we have the so these are the possible areas where we can find the application of this IoT and the AI. So this is the important aspect. So optimal microgrid control is the major concern for this. So if you want to perform microgrid control operation, so either we need to perform optimization of various objectives or optimization techniques. There are several optimization techniques which are available in the theory. So we can use any one of the optimization techniques with in order to serve the objective as per the user requirements, whether if we want to perform economic emission or economic or environmental aspect or maybe power flow performance. So energy management control, energy import export operations, load scheduling, variables because of integration of IoT systems into the. So finally, the objective here is minimizing the cost of generation and minimizing the conventional fuel usage so that the total power losses will be minimized, the security is maximized. Now, these are the different benefits what we will get out of this implementation. And the forecasting is the important aspect here. The forecasting gives us the scope where we have the provision of expecting the future load and the future shedding patterns of load setting patterns also. So based on the previous data, means previously available data with regards to the load or the quantity of the load scheduled or load utilized or power utilized at various points of power systems. In future, what could be the load or what could be the power flow through a particular system can be implemented, can be identified by applying machine learning algorithms. So and also based on the type of faults on a system, using machine learning algorithm, we can classify the type of faults based on the flow of current flow and based on the quantity of the voltage signals selected at a particular bus. So we can clearly identify and we can clearly classify what could be the fault, what is the preventive mechanism we have to be initiated in order to minimize the damage due to the fault. So these are the some of the aspects where we can find the application of this artificial intelligence and machine learning. This is the best slide. Now with this slide, let me close this presentation. So the first one is in power systems, we have got different points or possibilities to collect the data. So the data collection can be from different points of power system, like at generating station, transmission, distribution, and load centers also using relays and protection systems, where we have the availability of hazard measurement units and the SCADA-based, sensor-based systems, and the smart meters, and the distributed energy resources, controllable loads, power communication networks. Using all these, maybe power line, carrier communication, PLC, now all these communications are used in order to collect the data using various sensors. And based on the patterns of the voltage and the currents, now we have already trained and we did some of the projects in order to extract various features, like by looking at the data and by giving this data to the well-trained neural networks, automatically it identifies what is the current status of the system, whether it is operating in safer systems or not. So all these are possible because of developing various machine learning or neural network based algorithms. After that, once the status is being changed from normal to some abnormal conditions, what could be the status, whether it is a severe or not severe, or what is the severity percentage. We can do the performance of classification of the status based on the type of type of the fault or type of the problem which was initiated in the system. So approximate mapping functions are used based on the input variables, and finally the result what we will get for the better power system operation is the load or the user is supplied with the sufficient electrical power, so that the generation and load can be scheduled appropriately, and the quantity of the power drawn or supplied by the power system is within the limits. The user schedules and the reschedules if possible his loads automatically based on the energy price, the response can be supplied, and cybersecurity or thefting of the power is not possible. Fault detection, classification, and initiation of preventive and corrective actions is possible with this kind of application of AI and machine learning in power systems. This is the some of the typical AI methods, the conventional and fuzzy logic support vector machines and the Navi based method, KNN method, and all these are the different regression methods. All these methods are used in order to classify the system based on the conditions. So with this, let me have the ending of this session so that I'll get a possibility to interact with you. So that's all from my side. If you have any queries, let me know. Yeah.
Yes. Hello.
Am I audible?
Yes, sir.
Yes. Now, if you have any queries or any interaction, you can. So far, I have given a brief overview about application of IoT systems in electrical vehicles and also application of artificial intelligence and machine learning in electrical power systems. These are the two topics considered, and I have given the best. What the best I can.
Dear participants, if you have any queries, you can ask now. Our Suresh sir will be available, so you can ask any questions. If there is no any queries, we will wind up this session. Thank you, sir. Thank you for your sharing knowledge.
Thank you. Thank you, sir.
Navya madam will give the
Good afternoon, everyone. I Navya, and I wish to express my grateful acknowledgement to our distinguished resource person for session 2, Mr. V. Suresh Sir Garu, for his invaluable contributions in advancement in AI IoT in electrical engineering applications. And I kindly request all participants to complete the feedback and attendance form, the link which has been shared in both Google Meet and YouTube chat interfaces. Thank you for your esteemed presence. We're looking forward to seeing everyone at the FDP session tomorrow at 10 a.m. Please ensure your attendance. Thank you. Have a great day.